This is a short overview of liquid-liquid chromatography, the benefits it offers and how those benefits are achieved. Liquid-liquid chromatography is a preparative scale technique. The key benefits that it offers users are orthogonal to existing liquid chromatography methods such as reverse phase and normal phase HPLC or SFC. Theoretically, 100% recovery is achievable because there are only liquids involved and losses do not occur due to absorption. Only a single mechanism of separation, partitioning, is involved, enabling simple, robust and reliable scale-up. High stationary phase retention in the column, typically 75%, leads to low solvent usage. The mechanism of separation, partitioning, is shown by this simple test tube model. This demonstrates that with the correct selection of solvent system, different solutes are retained at differing rates due to the solutes partition coefficient in the solvent system. Only small differences in partition coefficients are required to enable high resolution separations. Selectivity is the dominant driver for separation and resolution of compounds rather than efficiency, as is the case in most other liquid chromatography methods. This difference demonstrates the orthogonality of the technique and is shown diagrammatically here. Conditions in a liquid-liquid column are very different to either an HPLC or SFC column. In fact, it is the complete reciprocal. In a liquid-liquid column, you have 75% stationary phase and the remainder is mobile phase. Because of this opposite relationship between stationary and mobile phase, high mass loadings of sample are achieved and the solvent usage required to purify them is very low, typically only a fifth and often as little as a tenth. As noted earlier, liquid-liquid chromatography has only a single mechanism of separation, partitioning. There are no secondary or tertiary mechanisms and therefore nothing else to impact on the method as it is scaled. As shown on the chromatograms of pharmaceutically-like compounds, the separation scale-up is volumetric, reliable, and gives robust results. Separations developed and optimized at milligram scale are scaled to higher scales simply and quickly. Liquid-liquid chromatography is just another liquid chromatography technique. It is operated in a similar way to other methods and uses pumps, detectors, software, valving that all scientists will be familiar with. Recent developments that allow automated on-demand solvent mixing, short separation times combined with integration with commonly used chromatographic software has revolutionized the ease of use of liquid-liquid instrumentation. Quite simply, you can consider the liquid-liquid chromatography instruments as an alternative type of column that provides unique benefits. Why is another liquid chromatography technique required? There are still issues that limit the effective use of liquid chromatography. These issues relate to low yields post-purification, sample solubility limitations, and insufficient sample loading capability. All these problems lead to the perception that liquid chromatography is expensive. Liquid-liquid chromatography can help resolve these challenges either as a standalone technique or in combination with HPLC or SFC. Liquid-liquid chromatography instruments are available for laboratory scale work through to pilot scale. This allows for separation methods to be transferred seamlessly to larger scales. Liquid-liquid chromatography also allows new operating modes to be used, because both mobile and stationary phase are liquids. For example, elution extrusion, where after 2 column volumes the stationary phase is pumped off, reduces overall solvent usage, or continuous chromatography is possible where the stationary phase is continually replenished, enabling 24/7 operation. Like other chromatography techniques, buffers, additives and pH can be used to change selectivity, but remember, all pH could be used because there is no silica stationary phase. The technique is used in the purification of many standard compounds, providing higher sample loadings, lower solvent usage, and solutions to previously unsolved problems. The technique has wide application to natural and synthetic molecules and peptides. Research is ongoing to apply the technique to biological compounds. In conclusion, liquid-liquid chromatography can bring you new capabilities. Although it is a standalone technique, it is complementary to other liquid chromatography methods rather than a replacement. It adds a new dimension to your chromatography toolbox.